Hey guys, uh, I believe the universe is not actually flat. Actually, it's more like a round tube, possibly a cone shape, like this right here. Um, because we know, and some scientists believe, and I honestly believe the gravity is basically inertia, just the same as astronauts in their machines, centrifugal machines that they're trained for to go into space. The centrifugal machines they use, they spin, and by spinning it creates gravity, and it pushes the objects or the astronauts to the edges of the spinning motion. So if you have a cylinder spinning, any kind of cylinder, uh, objects are going to tend to go to the inside of the circular motion, as normally they would, because normally objects tend to go in a straight line. And since it's not going in a straight line, what creates is they are pushed to the exterior inside of the circle, and that creates gravity. So in other words, the objects can be spinning this way or this way. Doesn't matter. In this case, if the object's spinning this way, um, uh, because it's spinning so fast, velocity, the whole space and time, the fabric itself, spinning, it creates inertia, and objects tends to go forward, but they can't. So what happens is they get attached to the side of the fabric of time and space. So these circles are basically the edges of time and space. It's the actual fabric. Uh, so they're stuck on the side. All the planets are stuck to the side all the way around. There's nothing in the middle. In the middle, it's empty. I'll explain why. See, this is inertia creating gravity. So that's why all the planets are stuck to the fabric itself. It warps the fabric. Um, because of the weight, the pushing on the this is the object, and it's warped right here. So that's how what happens with all the planets. They get warped underneath the fabric. Um, but I believe NASA is totally wrong on the distance of planets. All they say is some planets are 13 billion light years away, or whatever. Well, 90% of those planets, the distance is totally wrong. Because they don't take in account the actually warping of space and time, or in this case, uh, the fact that the universe is not flat. If it was flat, then in this case scenario, this is the Earth, and this is a distant planet or star. Let's say it's 13 billion. Okay, so yeah, it will be straight from here, straight line, straight line, straight line, straight line. Maybe correct. That'll be correct. But if you had a star going up here, and it's a straight line, let's say this is 10 billion light years. Okay, you have to take consideration. It's not the telescope they use is actually going to go straight line. So it's a straight line for the telescope, but the actual curvature of time and space is round. So now you have to take from this distance all the way around, all the way around, all the way around to get to this point. So the star no longer is 10 billion, even though the telescope says it's 10 billion. The distance, they're not adding the mathematical equations of the curvature of time and space. And because time and space is curved, the distance is more. You ever heard the saying, the faster route to one point is a straight line, and that's true. So this is a straight line, that's a telescope, but in reality, the time and space is curved. So all these sides, so here will be full planets or stars, all the edges, and you see in the top side of uh, the galaxy or stars or whatever. So yeah, this distance will be wrong. Now if you take this in consideration over here, same deal. See, I got a straight line over here. That's what the telescope gets. If you can see that. See, you get this line over here. That's a telescope. But now you have to take consideration not only the distance this way, straight line, but the reality is the curvature of the cone-shaped cylinder. The star, you have to add the curvature plus the distance. So in other words, that's further. Not only that's further, but you got to take consideration the curvature plus the point to where it gets to that point. So it's going to be further. Remember, they don't add the curvature or time and space, and that's what makes the difference of the distance. And same with this planet. See, this is further planet right here. The telescope straight line, but you have to add the curvature of this cylinder, so you add more distance to it. See, the curvature adds more distance to whatever the number is. And so this one should be correct because it's pretty much in the same level, and same distance, and same straight line. This is a straight line as far as I'm concerned. But these three planets, it's because of the curvature. See, all the planets will be on the edges. Inside the cone, or space and time, there's nothing. 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 All the stars all the way around, all the way around, all the way around inside the cone. There's nothing in the middle. Remember, rockets, spacecraft, even warped machines or warp drive, whatever you call it, can travel inside on the curvature. In other words, a spacecraft can travel all the way around. Okay, all spacecrafts can travel on top of the fabric itself, which is time and space. It's basically, you gotta realize the fabric itself is time and space. What I'm trying to say is, time and space, our universe is actually a real fabric. So they objects like say planets, rockets, spacecraft. Measure them as round spheres on a flat surface. Flat surface being space, what tends to warp a little bit. But what I'm trying to say is, a sphere will roll on a flat surface. So everything, including planets, spacecraft, everything is like a sphere. They roll on top of a flat surface that bends a little bit, warps a little bit, but they have to roll on top of a surface. This is a surface of the time and space, so they have to roll on the surface of time and space, even including rockets. Rockets have to roll or travel on top of the fabric as planets do. A point is, no aircraft or spacecraft, no warp drive machine, no vehicle spacecraft can actually travel in a straight line, because it's impossible with our technology. Not even warp drive. Warp drive works on top of the surface, which is on the skin of the fabric itself. They'll travel anywhere. They can go this way, they can go this way, they can go around, basically around the inside surface, but they can't travel from here to here because there's no way, there's no surface here. This is empty space right here. There's nothing here. So you have to go around here and to reach this planet. You have to use a rocket or a spacecraft to go around or around this way to get to this point. But from here to here, it's impossible. You cannot go through the middle. The only thing that we know that actually can do that, and I'll show you, is, I'll put it right here, is a black hole. See, a black hole, and you have two black holes combining. Let's put it this way. You got two black holes combining, trying to combine in their spinning motion. Okay, as they join, they shoot a energy this way up into the middle section. So this energy, okay, that's the only thing that I know that can go from the bottom, from this energy, massive, powerful energy of two combining black holes, shoots a stream of energy so powerful that it doesn't go on the side, shoots up straight up. And when it shocks, and when they combine, it creates a shock wave. And the shock wave goes in the fabric of time. So if it was over here, and you have two black holes colliding, the shock waves will go through the skin of the fabric of time and space until it reaches our planet or other planets. So it will go through around the skin. That's a black hole when they collide. But the shooting stream, the powerful beam that shoots up straight up, goes into the center of the universe and probably to the other side. So this is the black hole colliding. The shock wave or gravity waves, as we know it, will go through the skin around the circle, which is basically the skin of the cylinder. And those are the gravity waves. Will feel the planets will feel that. But the actual jet stream that shoots this so powerful, it goes into the nothingness. I call it nothingness because there's nothing here. There's no fabric or time and space. Basically, it's in between Uh, there's nothing here. But you can see the other side. That's why telescopes can see this. They can see objects on this side. Uh, um, if you're here, you can see this side, a straight line with the telescope, but you can't reach it. You have to go around it to reach this point, around the skin to reach this point. And only thing that reaches from one side to the other side in a straight line will be a jet stream so powerful from colliding black holes. That's the only thing I know on a universe that does that. Spacecrafts can't do that. They can't provide that powerful thrust to propel them in a straight line from one side of the skin of space and time to the other side of the skin of time and space. They have to follow the rules of the gravity of the fabric of time. They have to roll on top of the fabric. See, think of a bicycle. Bicycle has to roll on top of a surface, whether it be grass, dirt, pavement. It has to roll. A bicycle cannot, by itself, be flying. It could jump from point A to point B, but in reality, in space and time, we can't. Bicycles can't do that in space and time. Bicycles roll on the surface. They don't fly. Okay. In real life they jump, but they don't fly. Point is, bicycles do not fly. They have to roll to travel from point A to point B. So there's nothing in this universe that allows an object to fly from one side of the skin of the fabric itself to the other side. There's nothing that allows them to fly because they don't have enough power, thrust, or energy that a black hole has. So all aircraft, all spacecraft, all objects, planets, galaxies, everything has to roll on top of the surface, inside surface of the skin of the time and space, the fabric. So everything has to go in the skin. Nothing travels or flies. So what I'm trying to say is, no known object flies. Okay, they may seem like they're flying in space, but they're not flying. They're just above the fabric itself. There's let me put it this way. This is the atom, and this is an electron. And this is spinning right here. Okay, if you can see that. In the smallest scale, we have the atom and an electron. See, there's a space in between. There's no physical connection, but there's a connection attracting these things. So this is the atom, and this is the electron spinning. But I'm trying to say an example only, and nothing to do with this, but just trying to make it easier to understand. There's this invisible space that electron can't just be flying off, or electron can't go be further distance. It has to be an exact distance, not too close and not too far. Something attracts it and it holds it there while it's spinning. Same with objects. The Earth, okay, for example, there's a space in between the Earth and the fabric, just like the electron and the atom. There's a space in between. So all objects in the universe has a space between the object and the fabric of time, fabric of time and space. So there's always a space in here between the object, the mass itself, and the fabric of time and space. It looks like they're floating on thin air, or in this case, it looks like they're floating, but that's just a small section of space underneath. They're floating just like the atom distance from the electron. So the planets are actually floating slightly. They're not actually on top of it, but it warps the fabric of time. There's something in between, invisible, but allows them to have a small space around here. So that's with all matter. So all objects will have to, let's say this is a space rocket here. Right here, and flame coming up here. Everything has to travel in a circular motion, basically following the same fabric of time and space. See? So